Okay, let's dive into a classic physics puzzle. But honestly, wait till you see the solution. It has this surprisingly beautiful, almost magical answer hidden right inside it. We're going to explore what happens with just a ladder, a wall, and a very curious parrot. All right, so get this picture in your head. You've got a ladder, right? It's just resting against a wall, nice and simple. The top of the ladder is touching the wall, we'll call that point W, and the bottom is on the ground at point G. And then there's our hero, a parrot, just hanging out at point P. Not at the very top, not at the very bottom, but somewhere in between. For right now, everything is perfectly still. It's all balanced. But what if we introduced just a little bit of chaos into this peaceful scene? What if things start to move? So imagine this. The bottom of the ladder kicks out, sliding away from the wall. Naturally, the top starts sliding down. Our parrot is just holding on tight, going along for the ride. So here's the big question. What path does that parrot actually trace through the air? What shape does it make on its way down? Now, what's your first instinct? Your brain is probably screaming a straight diagonal line, right? Or maybe some kind of simple curve. I mean, that feels about right. But just hold that thought, because the real answer is so much more elegant than you'd probably guess. So let's do it. Let's pull back the curtain and see the hidden geometry that's really running the show here. It's time for the great slide. Okay, so if you did guess a straight line, you're in for a really cool surprise. The path is way more interesting than that. It's a perfectly defined, graceful, geometric shape. And there it is. Look at that. As the ladder slides, our parrot traces this absolutely beautiful, smooth curve. It's not a random wobble, not at all. It is a precise, totally predictable path. But what is that shape? That path, it's an ellipse. Well, to be exact, it's a quarter of an ellipse, a perfect, mathematically pure shape that just appears out of this really simple physical setup. So knowing what the path is, that's cool. But the really mind-blowing part is understanding why. Why on earth an ellipse? Well, the answer isn't really about complicated physics. It's all about pure, simple geometry. Yep, the entire secret is locked up in the relationship between the ladder, the wall, and the ground. And we can totally unlock it with a pretty straightforward proof. Okay, this diagram right here, this is the key to everything. Let's break it down. As the ladder is sliding, it's constantly creating two little right-angle triangles. You see the small one up top? That's triangle PCW. Now look at the bigger one on the bottom, triangle GDP. Now here's the crucial insight. No matter where the ladder is in its slide, those two triangles are always similar. Now, similar is a really important word in geometry. It means the triangles have the exact same angles. They're just scaled up or scaled down versions of each other. So the small triangle is always a perfect little mini-me of the larger one. This constant relationship, this is the engine that's generating our ellipse. All right, let's decode this thing. Because those triangles are similar, we can actually set up a really neat relationship between their sides. And this is where we turn what we're seeing into an actual mathematical formula. And here is where the magic happens. Since the triangles are always similar, the ratios of their sides have to be equal. That means if you take the parrot's distance from the wall, let's call it x, and divide it by its hypotenuse, which is that top ladder segment we'll call a, you get a number. And that number is always equal to the ratio from the other triangle. Its vertical side, y, divided by its hypotenuse, that bottom ladder segment, b. This gives us this perfect link between the parrot's x and y coordinates and the fixed links of the ladder. Now, you take that relationship, you do a little bit of algebraic shuffling, and boom, you get this incredibly simple and beautiful equation. And this isn't just a random jumble of letters. This equation is the mathematical definition of an ellipse. It's like its DNA fingerprint. The parrot doesn't have a choice. The geometry of the whole situation forces it to follow this exact path. And just so we're all on the same page, an ellipse is basically a squashed circle. You can draw one with two thumbtacks and a piece of string. Well, our sliding ladder problem naturally creates a piece of that very same curve. Now, this isn't just theory, okay? It's not just lines on a piece of paper. We can actually prove that this mathematical elegance happens in the real world. And check this out. This illustrates the point perfectly. This is a 3D printed model of our sliding ladder problem. You can put a pin in any one of those holes, and as the ladder slides, it traces a perfect elliptical path. The math holds up. It's a physical reality. So I think the big takeaway here is just
how cool this is. A really simple, everyday event, a ladder sliding down a wall, is secretly being guided by this beautiful, timeless mathematical law. It's a perfect example of the hidden order in the world all around us.
And it just makes you wonder, doesn't it? If a falling ladder is hiding this kind of amazing geometric secret, what other elegant mathematics are we just walking past every single day? What other beautiful patterns are just out there waiting for us to see them?